On July 17th, a coordinated barrage of drones and missiles struck the Muwafaq Salti Air Base in Jordan. The attack moved so quickly that personnel on the ground had almost no time to react. The impact killed 3 U.S. soldiers and caused significant structural damage to several buildings within the military compound. This happened at a facility protected by the Patriot and THAAD systems, the most advanced and expensive air defense networks in the world. The Pentagon immediately launched an official investigation to determine how these defenses were pierced, looking for evidence of a sophisticated new weapon. Investigators found that Iran engineered a way through these networks by pairing inexpensive, mass-produced components with public satellite data. The first phase of this strategy bypasses traditional military espionage. It relies on the fact that high-level targeting data is now a commercial commodity. Because U.S. bases are static, stationary targets, their coordinates can be purchased legally through high-resolution satellite imagery available on the open market. Once those coordinates are locked, the physical attack begins with a swarm of incredibly cheap, low-tech drones. These drones are not intended to be the primary strike force. They serve as tactical bait. As the swarm approaches, it forces the base's radar systems to lock on and fire their interceptor missiles. This creates a massive cost imbalance. The attacker trades a few $1,000s worth of disposable drones to force the U.S. to spend millions of dollars on interceptors, rapidly emptying the base's magazine. By the time the radars are saturated and the interceptor stock is exhausted, the base is left vulnerable to the actual lethal strike. With the primary defenses occupied or depleted, the heavy ballistic missiles are launched. Standard U.S. countermeasures focus on jamming the specific American GPS signals these missiles typically use to find their targets. To counter this, Iran developed guidance modules that read 3 networks at once: U.S. GPS, Chinese Baidu, and Russian GLONASS. If the U.S. military jams its own GPS signal, the missile's computer automatically uses the other 2 paths to stay on course. It's the equivalent of having 3 navigation apps running simultaneously to ensure the destination is reached. This capability relies on open, public signals. While it doesn't prove direct military assistance from Russia or China, it shows how Iran has integrated global satellite infrastructure into its own technology. By drawing from multiple redundant networks, these missiles become highly resistant to Western electronic warfare. The Jordan strike is part of a broader evolution. Iran has matured into a regional coordinator, employing layered, systematic tactics that share characteristics with the modern attrition warfare seen in Ukraine. This creates a logistical crisis. Intensive defensive operations have already caused U.S. stockpiles of Patriot and THAAD interceptors to drop by nearly 50%. This map illustrates the scale of the challenge. The U.S. must defend a massive area and critical choke points like the Strait of Hormuz with a shrinking missile inventory. This defense umbrella isn't limited to military outposts. It also protects extensive civilian infrastructure. That includes ports, desalination plants, and massive energy facilities that are vital to the regional and global economy. The core tension is volume and cost. A dwindling supply of million-dollar interceptors must defend a vast map against an ongoing influx of low-cost drones and unjammable missiles. Strategic reliance on exclusive, high-cost defense shields is being challenged by the reality of adaptable, open-source weapons. How do you think air defense systems should be redesigned to survive this shift? Let us know your thoughts in the comments below.